I built this robot so I could capture videos like this. I've named it Camero for Camera Robot because I have a great imagination, and it's completely open source, so you can build one yourself. All the instructions and files are on Hackster, link in the description. Camero moves in two axes. The first is the rotating turntable, and the second is the arm that swings a full 180 degrees around the turntable. There are simple controls to set the turntable rotation direction and speed, as well as the arm speed and the angle it moves to before it returns. And this thing is robust. It has a heavy steel base and very powerful motors, so it can smoothly carry even the heaviest DSLRs and mirrorless cameras. I started work on this robot several months ago when Cube Mars reached out and asked if I'd like to use their motors to build something. A big thank you to them for giving me the motors to sponsor this project. These are AK series actuators built specifically for robotics applications. Each unit contains the motor, a controller, and a planetary gearbox, all tucked into one compact package. And they're easy to work with because they're controllable through a CAN bus. My original design was pretty dang complicated with a total of 7 motors, but then I realized that I could achieve similar effects with just 2 motors and some simple edits added in post. And in fact, I think I'm going to eliminate manual control almost completely. I might still have some way to do basics for when, if you just need to move the arm for some reason, just to move the motors. But this kind of like, fancy real-time control, I think I'm going to just abandon that altogether. To understand what I mean, take a look at 2 videos. The first one is straight from the camera without any editing. Looks decent, being a step up from just using a turntable, but now look at what we can do with some editing to add zooms, translations, and speed ramping. As you can see, the combination of physical movement and editing is enough to make very dynamic videos. Am I good at this kind of editing? Not at all, but you get the idea. If you're sold, let's cover what goes into building a Camero. I designed the entire thing in Autodesk Fusion 360, and the assembly in the file is complete. So you can easily see how everything fits together and grab whatever model you need. That said, this does require a wide range of fabrication techniques to make. Several of the parts are 3D printable, and I used mostly Bamboo Labs PPA CF filament for that. It looks great and does a great job of hiding the layer lines within the texture, but is also really strong. The aluminum extrusion is standard stuff that you can just get off the shelf, though you'll want to tap a couple of M5 holes in the ends. But there are parts that need to be machined, both from aluminum and mild steel. I CNC milled most of the aluminum parts, as you can see here. and manually milled the steel parts. I also manually machined this aluminum cross brace part. And welding is required to attach these mounts to the steel base. If you don't have the equipment to mill the parts yourself, you can take advantage of this video's sponsor, PCB Way. PCB Way makes professional and affordable PCBs. In fact, they made the PCB inside Camero. But PCB Way also provides other great services, including CNC milling. If you want to build this robot but can't mill the parts yourself, just send them the models from the Fusion 360 assembly and they'll send you back a set of beautifully machined parts. Use the link in the description to get a $5 credit towards your first order. On the electronic side, I tried to keep things as simple as possible. I actually experimented with all kinds of control hardware and software, everything from Tango on a Raspberry Pi to ROS2 to completely custom firmware and software. While those allowed for more complex movements and features like recordable sequences, I wasn't satisfied with the performance. Eventually, I settled on a more basic approach, and Arduino Uno R4 Minima controls the motors through a CAN bus transceiver on a custom shield. That's the board that PCB Way made for me. That shield also contains 3 potentiometers and 2 buttons, so the user can set speeds and angles. The home button initiates the sensorless homing sequence, so the arm starts in the proper position every time. I'm pretty proud of that homing sequence, which monitors the arm motor's current to detect when it hits the stop block. And I also designed the PCB so it will work with the Arduino Uno R4 Wi-Fi too. I did that so in the future I or someone else can program additional features, such as more complex control through a smartphone app connected to Bluetooth. But for the time being, it just has the Arduino Uno R4 Minima and simple controls that I think are enough for most use cases. After painting the metal parts, assembly was pretty straightforward. Everything goes together with M3 screws and M5 screws, and T-nuts were things attached to the aluminum extrusion. I'm really happy with the way this turned out. It will help me record more exciting videos in the future, and it's sturdy as a tank. While I have built some robots in the past, they were always silly things without any real purpose. This is the first robot I've designed and built that is actually practical, and I'm proud of it. Remember, all the files and instructions are on Hackster if you want to build your own Camero. Thanks for watching.